All right, consider the graph of the function x squared minus 4x plus 6. Okay, that's a typo because we're not going to graph this thing. Oopsie. Instead, we're just going to look at the number line itself because that's really all it's about is the number line. We're going from 0 to 4. Find the area under the curve using 4 left-hand rectangles and 4 right-hand rectangles. Okay. Well, we are going from 0 to 4. And we want 4 rectangles. What's the difference between 0 and 4? 4. And if we want 4 rectangles, what's 4 divided by 4? 1. So what's the width of each rectangle? 1. So it was a little presumptuous of me to actually write the number line out because I was basically telling you the width was 1. So it may have been something else. It could have been like a half or a third, depending on how many rectangles you have. But it's a 1 here. Hooray. So we have 4 subintervals, 0 to 1, 1 to 2, 2 to 3, 3 to 4. Okay? So in part A, since we want left-hand rectangles, then you're only looking at the left-hand side of each subinterval. In this case, 0, 1, 2, 3. Is that okay? Remember, the width of the rectangle is 1. The length of the rectangle is given by the functional value. Because remember, we started at the left-hand side. We went up to the function, went across the width, and then came down. So the left-hand side of the subinterval dictates the height of the rectangle. So since the area of a rectangle is length times width, the first one would be g of 0. That's the length, times the corresponding width is 1, plus, what's the next one? G of 1 times, plus, times, plus, times 1. And we're done. Well, at least we're setting it up. Because here are 4 rectangles. Now we're multiplying by 1. It's boring, so the 1's not going to matter. You can rewrite it so that you pull the 1 out in front and then just add up the functional values. But again, since it's a 1, it's not going to make a difference. So how do we find g of 0? Plug it in. So if you would, please put in 0 into the function. And 1, and 2, and 3. And notice this would be a great example of a table for your calculator. So what do you get for g of 0? G of 1? 3? Yes. G of 2? Oh, there's a typo there. 2? And g of 3. So again, the 1's don't matter. What is 6 plus 3 plus 2 plus 3? Now, since we are not looking at the picture, it's not easy to know if this is an under approximation or over approximation. So we can't make that judgment. We'd actually have to graph this thing. Okay. So for part B, what numbers are we going to use for x if we want right-hand rectangles? Yeah, 1, 2, 3, 4, or 4, 3, 2. It doesn't matter. So again, the widths are all 1. So we'll have g of 1 times 1 plus g of 2 times 1 plus g of 3 times 1 plus g of 4 times 1. Notice 3 out of the 4 numbers we already used. And I think due to symmetry that this is also 6. So what's our sum? 14. Well, by golly, I hope that our real area is 14. Otherwise, we were lied to. But we find out the real area in the next section. But again, we don't know if it's an over and under approximation.